Hey everybody, happy Monday. It's day 148. Sure, you want to come say hi? Come on. Sure. So today in class, we're learning about what causes pitch to change. And part of this is how waves interact. And so my son made something pretty cool. He made this thing. What is this, Jackson?
That is a kazoo.
Okay. And how do you play it?
You gotta squeeze really hard, and you gotta blow like that.
And how do you change the sound? Do you know? He doesn't know. He's shaking his head. Well, we're going to learn how. All right? That's the whole point.
I think I know.
You think you know?
Maybe if you blow not very hard, it changes the sound
Try it.
to lighter. And then maybe if you blow hard, it changes the sound to lower.
Okay, try it.
No.
Okay. I'm going to borrow that.
Right.
That's okay. All right, so today we're going to use all these things. I've got a whole, bunch of stuff over here. We've got some straws, some scissors, some rubber bands, some popsicle sticks, some pieces of paper, and so probably you have some of these things at home. If not, I have some substitutions that you can use. And we're going to use those things at home. And one of the cool things you're going to do is you're going to make stuff like this little guy.
I thought that's to use the
Man, that's hard.
Maybe you're using it on the wrong side. I think you're using it on the wrong side.
You think so?
But it sounds pretty cool.
I'm going to pass out. Wait, I need that.
But I really need it.
Okay, so how did I get all of that out of this little thing? Well, I'm going to show you. Also going to show you how you can make one of these. And why it does what it does. So if you haven't done the warm-up yet, please go ahead and do so. Make your best attempt at all the questions. Even if you have to guess, go for it. And pause, and then come back. Okay, welcome back. So, high pitch, what does it sound like? Well, nope. That, right? And low pitch? Which of those do you think has a higher frequency? This one? Or this one? Which of these has a higher frequency, Jackson? Or first one or second one? First one. Yeah, he's right. So the little rubber band that's in here is vibrating faster. See the rubber band in there? When it's going, it's vibrating faster. So higher frequency, higher pitch. Oh, I know you have your little maraca. Shake it. Cool. So if I ask you to draw a longitudinal wave, that's going to look like this. All right. The one that looks like an S that's laying down. A transverse wave looks like this. Looks like a bunch of particles where sometimes they're compressed and sometimes they're rare or expanded. We saw a picture of that in your quiz. Okay, Jackson, it's time for your music class. Go inside, buddy. So looking here, this one here, transverse wave, and this is a longitudinal wave. And so this has areas of rare material. So this is rare. It's called a rarefaction. And this is areas where things are compressed. So it's called a compression zone. And the wavelength, much like the wavelength goes from peak to peak or from trough to trough, on one of these waves, it goes from peak to peak or compression to compression, or from the middle of a rarefaction to the middle of another one. All right, so that's a full wavelength on one of those. And getting back to our warm-up for today, how does sound travel? Well, the particles compress and expand like this. So which of those would that be? Would that be one of these transverse waves, or is that a longitudinal wave? Second one is longitudinal wave. And if a compression from one wave interacts with a rarefaction from another, that's just like a peak from one interacting with a trough from the other, and they cancel out. This would sound like this. See what I did there? Quiet, silence. Okay, I gave you a review to the guided reading, and you're going to want to go through this, make sure you got all the answers right. If you have any questions, please do let me know. It's a lot, so I'm not going to go over it all right now, but it's there. All the answers are in red, and this is stuff that you want to start to memorize. And somebody's on there right now, so that's good. Okay. Quiz 7. So quiz 7 went pretty well, and there were a few questions that folks struggled with. And so, pause here for a sec. All right. Oops. So the quiz went really well. Most folks got pretty good scores. The averages for most of the questions were pretty high, as you can see here. 87% of people got question 1 right, 93%, 87%, 93%, on down the road, till we get to question 7. Increasing the damping does what to the amplitude? Well, if you increase the damping, it's basically increasing the friction. It means that the wave loses energy. If you took like a hose or a string and you whipped it, right? You whipped it like that, you'd get a wave, right? And that wave would travel, but it would die off over time. And so that's because there's resistance, and so what does that do to the amplitude? It reduces it until the wave disappears. Okay, next, the other ones that folks had trouble with were these last two, the math problems. So a wave occurs 20 times in 4 minutes. You have to find the frequency, which is cycles per second. And so that means something has to change here. We've got minutes for the time. It needs to be in seconds. So you have to figure out what 4 minutes is in seconds. It's 4 times 60, 360. So it would have been 20 times in 360 seconds, or 20 divided by 360, 10 divided by 180. It's 1/18th, whatever that is, 0.0 something. There we go, 5/6. And for this one, the time it takes for something to travel 20 meters, well, if you know how fast it's going and you know the distance, it's the time is just going to be some simple math with that. The frequency doesn't get involved here. So speed or velocity equals distance divided by time. And so if we want time, it would be time equals the speed divided by the distance. Did I say that right? I might have flipped that. Sorry, it would be, so speed equals distance over time. And so time is going to be equal to distance over speed. There we go. So it would be 20 divided by 343, which gets you a fairly small number. Hey, look, I can just reuse. There we go, 0.058 to 366, or 0.583. Okay, so that's it. That's it for those. On to the stuff for today. New bits. So I got a changing pitch lab. This is a really, really fun activity. Pull it up. And this is what I was showing you earlier. So today you're going to see how you can, one, make sound with some common household stuff, and then two, see how you can change the pitch. So the first thing we're making is a straw oboe. This is a basic version of this instrument here.
Hello, I'm Bruce Shady. Today in How Made Science, I thought we'd take a look at slide whistles. Now it's
Okay, we're not going to make one of those because that's much more complex. But if you have this stuff at home, some pipe, a piece of doweling, and some basic tools, you can make one of these. Now, they're pretty cool. This is all basic stuff you could get for about $4 at your local hardware store. Okay, so we're going to take a straw. Hopefully you have a straw at home. If not, sometime in the next day or so, maybe you can venture out and get yourself a straw. It's one of these guys. And so what you're going to do is you're going to flatten the straw. I'm just going over these steps here. You're going to flatten the straw like we see here. You can just use your teeth to kind of squeeze it down. You can squeeze it flat like this. And then you're going to cut out some parts. I already did this here. See that? So when I squeeze this down, you can see, there we go. I've got this kind of, it's not quite to a point. I left a lot of flatness here. And this is just about a little bit more than half my fingernail. And then what you're going to do is, following the steps, you're going to put your lips past your little cuts, right about there. And you got to kind of feel around for where the sweet spot is. So sometimes you start, you put your lips here, and nothing happens. So you go in just a little bit further. Oh. Okay. Wow, that's pretty cool. This one, I think I made the pieces, the little alligator mouth, a little bit too long. It doesn't work very well. So, you try again. Maybe you can cut a little bit of this off and try again. So, you can hear some sounds. One thing you can do, if you just use a little bit of the straw, is you can take a bigger piece of straw and you can try. See, I screwed that up. So, start over. This is the cool thing about this. You can always just start over. It's no big deal. You want to get both sides as even as you can. What do you think is going to happen? This is longer. Same? Different? What if I put two of these together? You can do this. All you have to do to put two of them together, you don't need any tape. You take this thing, you squeeze it, and I call this taco. So what I did, where's the camera? You see that? So I made it flat, and then I folded the flat like that to make it smaller. And then I'm going to stick it in here. And then I'm going to try and get it to open back up. I guess I was a little bit too aggressive. Oh, man. Too much tacoing. Okay, I think I got it. It's a little funky. This might work. Huh? It's having a hard time because it's not straight in there. Let's try this end. The struggle is real. Nah, that's funky too. Well, so you can just hold them together. So there you go. Maybe that's better. Just hold them together. You saw that as this got longer, what happened to the pitch? higher or lower. So something about the length of the tube affects the sound that comes out. What's up with that? Think about why that is. So there's some questions here to think about. We think about a slide whistle. And next thing is to make a tongue depressor harmonica. So this you can make with a tongue depressor. That's how my son made his. He used a tongue depressor, a couple little sticks as spacers, a couple rubber bands to hold it together like this, and then one rubber band strung across. I'm going to show you how to do this from scratch. Okay, so here are my materials. I've got a couple popsicle sticks, a rubber band, and some pieces of paper, just strips of paper, and they don't even have to be this long. They could be half this size. So what I'm going to do first is I'm going to take my strips of paper and I'm going to wrap them around each end of the popsicle stick. This is the green stuff that you see here on the screen. See, this is what happens when they're too long. This takes forever. Okay, so that's one piece. I'm going to put that down for a sec. And then over here, I'm going to take my rubber band. And this is easier if you have bigger things like this. And by the way, you can do this with other stuff. I got this to work. I took a couple of butter knives and put the flat parts together like so. I did the same thing with the paper, except I made my paper strips smaller because there's not a lot of real estate here. And then I put a rubber band across one of these. All right, so paper on one of them, rubber band across the other one, like this. It's tough with the knife, but it works. See? So, popsicle stickers are better because you can adjust the frequency, but you get the gist. So I take my little guy, this one with the paper, this one with the rubber band, put them together, and then you want to blow through here. I'm going to make these a little bit wider. A little bit wider. All right, I'm going to come back real tight. Do you hear the difference? Hopefully you can hear it before I run out of breath. It changes. Now you may not have any of this stuff at home, and hopefully then you can get some access to this stuff. What's this? Piece of grass. If you go pick grass and you try and do this a few hours later, you'll end up with this. This is a rolled up one of these because it got dehydrated, so you can't wait. But you take one of these and you fold it. It's got a curve in it. All right, so we got the spine on the bottom. You want to fold the spine together so that it's curved open like that. All right, and then if you make it tighter, higher pitch, a little bit wider. Oh, I think I blew it out. Lower pitch. There's other ways to change the pitch, but that's one of the ways, right? Is to adjust the length of the waves. So, lots of ways to get this done. All right, try and make some sounds whatever way you can, and then think about the answers to these questions, and then we'll talk about them later. That's it for today. And if you need to go and get, wrong page. If you need to go and get materials today and do this tomorrow, well, cool. That works. All right, do that. If you have any questions, let me know. If you're having a hard time, send me a picture or a video of what you got going on, and I will help you out. Okay, have a great day. See you later.